Starting from the location where she moors her boat, which is here at the top, a fisherwoman wishes to visit A, B, and C where she set her nets. If the times are given in the figure below, what route would be optimal? So we're going to start here. We want to get to these three places and get home in the least. Again, I would have to inspect all three tours and then choose the one with the least. So I'm going to avoid this 111 edge if I can because it has the greatest weight. That doesn't ensure that I'll get the best tour, but I don't want to calculate all three. So from here, it looks like to avoid that edge, I'm going to go 65, 102, 93, 84, and I'm willing to bet that's the best. If you have a better one, let me know because there may be actually a better one, but I don't want to calculate all of them. So I'm going to go down here, over there, up and up. Which is down here, over there, there, and there. Again, to be positive, we'd have to calculate all three tours, add them all up. 42. For the two complete graphs that follow, find the cost of the nearest neighbor tour starting at B and the tour generated by sorted edges. So, 42, here is our two graphs. So, nearest neighbor starting at B. Starting up here, the cheapest edge I could take is going to be 18. So in 42, I'm going to start at B and I'm going to go to A because that's my cheapest edge. From A, I've already visited B. My choices are 69, 65, and 38. I will go to E because that's the cheapest. I've already been to A and B, so I have choices of 73 and 71. So I'll go to D because that's the cheapest. Now I've already been to E, A, and B, so I only have to go to C, which means I have to take 62 and then return to B. So that would be the tour. And it says to just give the tours, it doesn't say to find the weights, so that would be my tour. For the second graph, starting at B, I have 31, 39, 68, and 43, so I'm going to go B to D. Then from D, I have 62, 43, 54, and 71, so I'm going to go to A for 43. Then from A, I've already been to B and D, so I could take 47, 28, 59. I'm going to go to E. And then I've already been to B, D, A, and I'm at E, so I've got 50 and 38 left. So I'll go to C for 38, and then I have to go to F because that's all that's left. So then to F and back to B. Both of those were nearest neighbor, starting at B. I'll go back to this top complete graph and we'll do sorted edges. So, sorted edges, this was nearest neighbor, starting at B. Sorted edges will tell me I'm going to just pick the cheapest edge in the graph. The cheapest edge is 18. So I'm starting, well, maybe it's easier to just draw this. Okay, I'm going to throw that in because it's the cheapest. After I have the 18, I'm looking for the next cheapest, which is 38. So I'm going to put that in. After those two, I'm going to look for the next cheapest edge, which I think is 47 and doesn't violate a Hamilton circuit. So I'm going to put in 47. After 47, I'm going to look at 56. 56 here would complete a small circuit. So I'm not going to do 56. Next is 62, which doesn't violate, so I'll put it in. And now I'm out of options. I've got to go there because it's the only way to complete the circuit. Then the other graph doing sorted edges. Again, I'll just draw this because I think it's easier. Okay, so cheapest edge in the whole thing is going to be 8, so I'm starting there. After 8, the cheapest edge is 28, so I will put that in next. 8, then 28. Next after 28 is 38, no, 31, which doesn't violate a Hamilton circuit, so I'll put it in. 31. Next is 38. Yes, and 38 goes there, which does not violate a Hamilton circuit, so I'll put in 38. Next is 39 going here, but that would create a small circuit here, so I will not put in 39. 42 goes across here, does not violate a Hamilton circuit. And now I'm going up, over, down, and over, over. So I still need more edges. So that was 42. 43 here would put 3 edges going into C, so I will not add 43. 47. Oh no, I have another 43 there, which would create a smaller circuit. 43 is 47 the next? No, I'd already looked at that. Where am I going? Okay, I've got to look at what I have. I'm going up, over, down, and here, here. So they are connected there. So I'm ending there and ending here. I actually have to connect those two. It is hard to see this. I'm going F, D, to B, A, to E, to C, and back to F. So that would be the sorted edges tour. Part B, how many Hamilton circuits would have to be examined to find by the brute force method the actual answer? Well, this is going to be 6 factorial because there are 6 vertices, which is crazy. We wouldn't examine them all. Invent an algorithm. Oh, and I asked you to skip that because I think it's a dumb question. So 43. We have to take 5 passengers from an airport to different downtown hotels. Is it traveling salesman, Chinese postman, or Euler circuit? So he has to visit hotels, which are locations, not edges. It has to be a traveling salesman. 43. Traveling salesman. I will stop at 43 and make another video for the rest of these. Thanks.